So good evening, welcome to Sakala Vidya educational channel. So welcome to engineering mathematics 2 classes. So in the last session we had a discussion on introduction on differential equations. So we have studied up to singular solutions. So today we are going to discuss about how to form a differential equation. Okay, now let us move to the concept of how to form a differential equation, and also today's session we shall solve some problems based on formation of differential equation. So formation of differential equations, differential equations. Okay, today let us discuss how to form a differential equation. So now in general an ordinary differential equation is obtained by eliminating the arbitrary constants, let us say C1, C2, C3 and so on Cn from a relation say pi of x comma y, C1, C2, C3 and so on Cn is equal to 0. So that means actually by eliminating the arbitrary constants from the relation, then we get an ordinary differential equation. But here the important thing means how to eliminate the arbitrary constants. If we are able to eliminate the arbitrary constants, we get a eliminant. That eliminant is known as differential equation. So that is ordinary differential equation. So for example, let us say this is equation 1. So how to eliminate these n arbitrary constants means, so we need to differentiate it. Actually here we can call where C1, C2, C3 and so on Cn are called arbitrary constants. So in order to eliminate arbitrary constants, we need to differentiate it. Arbitrary constants. So that means actually differentiating equation 1, successively with respect to x for n times, and eliminating the n arbitrary constants from the obtained equations, we get a differential equation. So now, so that means actually here differentiating equation 1 successively with respect to x for n times, because as it contains n arbitrary constants, so it has to be differentiated for n times, so n number of times, and eliminating n arbitrary constants from n plus 1 equations. So already the first equation is given one, that is a relation. So by differentiating successively for n times, we get n equations. Total there are n plus 1 equations. From n plus 1 equations, we need to eliminate n arbitrary constants from n plus 1 equations. Okay. We get a differential equation f of x comma y, y1, y2, y3 and so on yn equals to 0. So it is also called, it is a general equation, general solution. It is the general solution. Sorry, it's not a general solution, it's a differential equation. This is ordinary differential equation. Okay, right, like that we shall get it now. So let us solve the problems now. This is very, very important now. Problems. Let us discuss problems. So all of you look at the screen, note down the question number 1. Form the differential equation by eliminating arbitrary constant y equals to, or y is equal to c times e power sin inverse x. Okay. So now form the differential equation by eliminating arbitrary constant. Here arbitrary constant is c. By eliminating c from this equation, we get the eliminant, that is nothing but differential equation. By eliminating the arbitrary constant c from the equation, y is equal to c times e power sin inverse x. Okay. So let us try to figure it out, this question now. Let us try to solve it now. Right. Let us try to solve it. Now see, let us go for solution. How to solve this one? See, given equation, write down first. Given equation. See, given equation is y equals to c times e power sin inverse x. Now, how many arbitrary constants are present in the given equation? Yes, you are correct. There are only one and only one arbitrary constant. So, how many times as it to be differentiated? How many times we need to differentiate? Yes, exactly correct. It has to be differentiated for one time only. So, write down now differentiating. So, differentiating both sides with respect to x, as it contains only one arbitrary constant. So, what do you get now here? So, now we get derivative of y with respect to x is nothing but dy by dx. So, now the constant common d by dx of e power sin inverse x. So, how to differentiate e power sin inverse x? So, let me explain the concept here. So, what is the concept means? D by dx of e to the power of f of x, e to the power of some function. E to the power of x differentiation is e to the power of x. In the similar manner, e to the power of f of x is e to the power of f of x. Again, f of x derivative should be written. Multiplied with f of x derivative is f dash x. Am I correct now? So, with the help of this formula, so we can write c times e power sin inverse x differentiation is e power sin inverse x into d by dx of derivative of sin inverse x, just like f of x derivative. So, let me write once again what is the derivative of sin inverse x with respect to x. D by dx of sin inverse x. Derivative of sin inverse x is 1 upon root over 1 minus x square. So, please do remember this formula. So, now we can write, so this equals to c times e power sin inverse x and multiplied with 1 upon under root of 1 minus x square. See, if you observe, see equation 1. What is equation 1? Let us say this is equation 1. Equation 1. The c times e power sin inverse x is nothing but y. So, c times e power sin inverse x is replaced by y. So, now in the place of this one you can replace y. So, we have dy by dx is equal to, so y times this one, y times 1 upon under root of 1 minus x square. So, multiply both sides with root of 1 minus x square. What do we get now here? So, multiply both sides with root over 1 minus x square. So, what do you get now here? Root over 1 minus x square times dy by dx equal to y. So, now let us transpose y to the left hand side. So, we get root over 1 minus x square dy by dx minus y is equal to 0. So, this is the required equation. So therefore this is the required differential equation. This is the required differential equation. Differential equation. I hope it's very clear to you. Right. Okay, let us move to second question now. Second question. Form the differential equation. Form the differential equation. Form the differential equation by eliminating arbitrary constants y square is equal to x minus c whole cube. Okay. So let me read the question once again. All of you read the question carefully and look at the screen. So try to solve this problem. So if you want to try this problem, just pause and do on the paper, and after that you can check your solution also. So if you want anything, you can live chat also, because actually I put in subscribers only mode. So if you want to if you want to live chat with me, you need to subscribe first, then after you can live chat. Right. So let us solve this question now. So given equation, write down. What is the given equation? That is the relation between x and y. So given equation. So given equation is y square equals to x minus c whole cube. Say equation 1. So now how many arbitrary constants are present in the given equation? So there is only one arbitrary constant. So that means we need to differentiate for only one time. So that you must remember. Right. Differentiating both sides Ramu Tikiseti, it is also useful for your DSC, right? Differentiating both sides with respect to x. Okay, let us differentiate. So d by dx of y square is equal to d by dx of x minus c whole cube. See, my dear students, you remember these concepts. These concepts are very important. See, d by dx of y to the power of n, y raised to n. This is equal to n times y to the power of n minus 1 into y derivative with respect to x, dy by dx. This is the first concept you need to remember. Second concept you need to remember, d by dx of x plus a whole to the power of n. So this is equal to n times x plus a whole to the power of n minus 1. Again derivative of x plus a with respect to x, that is 1. So you get n times x plus a whole to the power of n minus 1. So let us make use of these two concepts. So in order to find out the differential equation here in this case, right, let us proceed. D by dx of y square means 2y. Again derivative of y with respect to x, dy by dx. is equal to, this is 3 times x minus c whole to the power of 3 minus 1, that is 2, multiplied with the derivative of x minus c is 1, so that we get 3 times x minus c whole square. Okay, for our convenience we can write the dy by dx means, so dy by dx means you can write y1 also. So for further simplifications, so this can be rewritten as 2y y1 equal to 3 times x minus c whole square. So from this we are able to find out x minus c whole square value. See, x minus c whole square is equal to 2y y1 upon 3. Say this is equation 2. Now if we are able to eliminate c from equation and equation 2, we will get, that is called eliminant. That eliminant is nothing but differential equation. So the differential equation will be formed. So let's see how to eliminate actually here c value from equation 1 and equation 1 and 2. So just if you observe, here we have x minus c whole cube. If you are able to write x minus c whole cube as x minus c whole square, then in the place of x minus c whole square we can substitute 2y y1 upon 3, so that we get the differential equation. So that means once again you consider here equation 1. So consider equation 1. Consider equation 1. What is the equation 1? That is, equation 1 is nothing but, that is y square equal to x minus c whole cube. Squaring on both sides. Squaring on both sides. Squaring on both sides. See, if you square on both sides, what do you get? Let us see. So here you will be getting y square raised to 2 and x minus c whole cube, again it is being raised to 2. See, I will tell you one interesting factor logic also. A to the power of m whole to the power of n can be written as a to the power of n whole to the power of m. So both are equal to a raised to mn, m times n. So that means this we can write now. So y to the power of 4, 2 to the 4, and this can be written x minus c whole square whole cube. But we have here, go back, x minus c whole square is equal to 2y y1 by 3. So x minus c whole square is equal to 2y y1 upon 3. So let us substitute x minus c whole square by 2y y1 by 3. So let us substitute. What do you get now here? 2y y1 upon 3 whole cube. So after prior simplification, it can be written 2 cube is 8, this is y cube and y1 cube upon 27. So cross multiply. If you cross multiply, what do we get now here? 27y power 4 equal to 8 times y cube y1 cube. The simplification can be made here. So here y cube times y. So that means 8 y1 cube is equal to 27y. So this can be written as 8 times y1 cube minus 27y equal to 0. So this is the required differential equation. This is the required differential equation. I hope it's very clear to you. It's very important problem. So you practice 2 or 3 times so that you can perform better in the examination. I hope you might have followed. So let us proceed for the next problem. So third question now. So third problem. Form the differential equation form the differential equation by eliminating arbitrary constants y equals to a times e power x plus b times e power minus x. So, in this given equation, how many arbitrary constants are there? Yes, here two arbitrary constants are there. One is capital A, another one is capital B. So, let us eliminate capital A and capital B to find out the differential equation from the given equation right now. So, let us try to solve this question now. Given equation is y is equal to a times e power x plus b times e power or e raised to negative x. Say this is equation 1. So, differentiating both sides with respect to x. See, my dear students, what do you get now? Derivative of y is dy by dx. Next, d by dx of a times e power x plus b times e power negative x. So, this is actually, in order to differentiate right hand side, we have u plus v formula in differentiation, u plus v rule, sum rule also we can say. D by dx of u plus v is equal to u dash plus v dash. So, now this can be written as a times d by dx of e power x. This is one of the standard result, plus b times d by dx of e raised to negative x. So, my dear students, please remember these two formulae, d by dx of e power x. This is standard result. Derivative of e power x is e power x. So, d by dx of e power negative x. So, that is e power negative x multiplied with derivative of negative x is negative 1. So, obviously, this is negative of e power negative x. This is the derivative of e power minus x. So, let us substitute this equal to a times e power x plus b times this is negative e power minus x, because the derivative of e power minus x is minus e power minus x. So, this can be written as a times e power x plus into minus minus. So, b times e power minus x. So, again differentiate with respect to x in order to eliminate both the arbitrary constant. They are nothing but a comma b. So, differentiating again differentiating both sides with respect to x. So, now again it is being differentiated with respect to x. So, what do we get now here? Dy by dx becomes second derivative. So, that means we can write d2y by dx square is equal to d by dx of a times e power x negative b times e power minus x. So, this we can write again a times d by dx of e power x, negative b times d by dx of e power minus x. So what is the derivative of e power x with respect to x? Yes, e power x. So what is the derivative of e power minus x? That is negative e power minus x. So a times e power x, negative b times negative e power negative x. So this can be rewritten as a e power x, negative into negative positive, plus b e power minus x. So what do you observe from the given equation 1? A times e power x plus b times e power minus x is nothing but y. So that means from equation 1 we have y is equal to a times e power x plus b times e power minus x. So that means what shall we do now here? Here instead of a e power x plus b e power minus x, we can replace y. So now this is being replaced by y. So we get this is equal to y. Now transpose y to the left hand side, we get therefore d2y by dx square negative y is equal to 0. So this is the required differential equation. Okay, I hope you might have followed this one. Okay, let us proceed for next question. So fourth problem. Are you ready? Right, fourth problem. All of you note down the fourth question. Form the differential equation by eliminating arbitrary constants y equals to ax cube plus bx square. Okay, so that means how many times we need to differentiate here? We need to differentiate it for 2 times, because as it contains 2 arbitrary constants a comma b. Right. So let us try to solve this question now. What is the given equation? Given equation is y is equal to ax cube plus bx square. Say equation 1. Differentiating both sides with respect to x. Now dy by dx equals to d by dx of ax cube plus bx square. So what do you write now here? A times d by dx of x cube plus b times d by dx of x square. So my dear students, remember this formula. D by dx of x to the power of n is equal to n times x to the power of n minus 1. So using this simple concept, this problem can be solved. So this we can write a times x cube differentiation is 3x to the power of 3 minus 1 2 plus b times this is 2x. This equals to 3ax square plus 2bx. Now this dy by dx also we can write dy by dx, we can write another notation also, y1 also you can write. So now we have this is equal to y1 equals to 3ax square plus 2bx, say equation 2. Now again differentiating both sides with respect to x. Okay. Now so 1 minute. Let me copy this one and I will substitute in this here now. Right. So this is equation 2 now. Equation 2. Differentiating. So 1 minute. Again differentiating both sides with respect to x. With respect to x. Same formula we need to use, that is known as power rule, power formula, x to the power of n derivative only. So y1 derivative is, we can write y2 3a times d by dx of x square plus 2b times d by dx of x. So this equals to 3a times derivative of x square is 2x plus 2b times x differentiation is 1. So we can have this is 6ax plus 2b, say this is equation 3. So let us rewrite all these three equations. So now we have so what is the first equation? First equation is y is equal to a x cube plus bx square, that can be written like this, y minus x cube times a rewritten minus x square times b equal to 0. This is equation 1. Second equation can be written as y1 minus a times, sorry, 1 minute. Let me write 3x square times a minus x times 2b, sorry, 2x times b. Okay, I will rewrite this equation once again for better understanding. y1 minus x square 3x square times a, right, plus 2x times b equal to 0. This is second equation. From third equation we can have like this, y2 minus 6x times a, right, plus 2b times 1 times 2b. 1 times 2b. So 1 minute. We can write this is 2b, negative 2b, negative 2b. Okay, negative 2b equals to 0. This is equation 3. So from these three equations we need to eliminate a comma b. So in order to eliminate a comma b, we need to make use of the concept of the determinants. Eliminating a and b from equations 1, 2 and 3, we get the eliminant, that is called, determinant is called eliminant, we will get it. Okay. So let us take all these three equations, right. Okay. So these are the actually three equations. Now write down here, eliminating a and b from equations 1, 2 and 3, we get, see, determinant of here y, y1, y2. Next, what is the a coefficient in the first equation? So minus x cube, negative x cube. Here negative 3x square in the second equation. A coefficient in third equation is negative 6x. Next, b coefficient is negative x square. Second equation, b coefficient is 2x. So you can check once again, wait. This also negative, sorry, negative you need to write, negative. This also negative, right, negative 2x. Here actually 2b, negative 2x you have written, here b is negative 2. So negative 2 equals to 0, write down. Just find out the value of determinant so that we get the differential equation. So expand by C1, expand by C1, expand by column number 1. So expand by column number 1 means you need to remember like this symbol. So plus minus plus, minus plus minus, plus minus plus. So that means these symbols you need to remember. So y into, you will write, eliminating the first row, first column, the determinant of this one. So the determinant we can write like this, negative 3x square into negative 2, that is 6x square. This is negative 6x into negative 2x, 12x minus 12x. And next this symbol is minus, so negative y1 multiplied with deleting this row and this column. So minus x cube into minus 2, that is 2x cube, 2x cube. So negative 6x cube, negative 6x cube, right. And this sign is plus, so y2 times deleting this row, this column, minus x cube into minus 2x, minus into minus plus, we have 2x to the power of 4, and this is 3x to the power of 4 but negative 3x to the power of 4 equal to 0. So let us simplify this one now. So here you will get it now, this one, 6x square y minus 12xy. So 6x square, sorry, 1 minute, this is 12x square you will be getting. So wait 1 minute, this is minus 6x square y, this is minus 4x cube into minus y1, So this we will get 4x cube y1. Now this is minus x to the power of 4 y2, minus x to the power of y2 equal to 0. So multiply negative 1 on both sides, multiply negative 1 on both sides, So if you multiply negative 1 on both sides, what do you get now here? Negative x to the power of 4 y2 becomes x to the power of 4 y2, and this becomes negative 4x cube y1, and this negative becomes positive, so plus 6x square y equal to 0. So this is the differential equation. This is the required differential equation. So that means if you want to simplify, you can simplify also. You can take out x square common. So x square y2 minus 4x y1 plus 6y is equal to 0. So therefore we get x square y2 minus 4x y1 plus 6y is equal to 0. So this is the differential equation. So this is the required differential equation. Okay, I hope it's very clear to you. So let us try to solve one more question. This is question number 4. Yes, question number 4 we have completed, right? Okay, tomorrow we shall solve remaining problems. Thank you. Bye bye.